When we talk about linear equations, we're talking about equations that actually form a line as the answer. Linear equations in two variables simply means that they can have x or y variables. They cannot have anything else. We can't have p's, q's, n's, but we can have x's and y's, and we can have both x's and y's, or x or y. We don't have to have both. So a linear equation in two variables has a specific format. Ax plus by equals c. A, b, and c are real numbers, and the only other rule is that both a and c and b cannot be 0. If a and b were both 0, we would have no x or no y variable because they would be multiplied times 0 and they would disappear. So remember these rules, okay? I've written 4 things down for your linear equations in two variables. First, they have to have an equal sign. No equation can be an equation without an equal sign. Number 2, they must have either an x term or a y term, and they can have both, but they can't have any other variable terms. No p's, n's, q's, no other letters. Number 3, they cannot have any exponents of the x or y term other than 1. In other words, if x squared was a part of the equation, it would not be a linear equation in two variables. And number 4 is they have to have only real numbers. If you wonder what real numbers are, go back and look at lesson number 1. That gives you quite a group of numbers that you can pick from. Everything else is flexible, and really everything else is pretty optional. Linear equations can look like many different forms. They can take many different formats. So I've given you a block in the center of examples of linear equations in two variables. And I want you to take these examples and remember the format. You might want to write it down again. Ax plus by equals c. Remember, a, b, and c represent numbers. X and y are the variables that you can have. Example number 1, 2x plus 3y equals 4. What I'm asking is this a linear equation in two variables? A would be equal to 2. It's the coefficient of the x term, so it's a 2. B is equal to 3. It's the coefficient of the y term. And C is equal to 4. It's the exact same format as our model. This one checks. It definitely is a linear equation in two variables. Let's look at another example. Example number 2. 2x equals 4. Well, that does not look like our model. However, let's take a look and see if we can figure out what a, b, and c really could be for this to still be a linear equation in two variables. If a is equal to 2, a is the coefficient of the x term, and a in this one is equal to 2. B is whatever is multiplied times y. The coefficient of y has to be 0. Why? Because I don't have a y term. The only way the y term could disappear is if it was multiplied times 0. And next, those are equal to my final number, which is 4, so C is 4. It looks different if one of the numbers is multiplied times 0, if one of the coefficients is 0. But let's take a look at some other examples and see what else it might look like. Number 3, another good example, 3y is equal to 4. What happened to the x term? The x term, a was equal to 0. When a is equal to 0, the x term disappears. B is equal to 3 because that is the term that's multiplied times y, or the number that's multiplied times y, and C is equal to 4 in this one. Your next example, number 4, 2x plus 3y equals 0. For 2x plus 3y equals 0, you're going to consider that the coefficient of the a term is 2. I'm sorry, the coefficient of the x term is 2. In other words, a is equal to 2. The coefficient of y is 3, and c is equal to 0. Those are the situations you can find yourself in when one of the terms is equal to 0, when a, b, or c is 0. But it's still a valid linear equation in two variables. Now, let's take a look down here at the next example, which is I'm going to call number 5, and see if it still fits our model. Can you find an A, a B, and a C? Well, if I look, I see that the coefficient of the x term, which is A, is going to be negative 2. The coefficient of the y term is also going to be a negative 1/3. It's a fraction, but that's okay because fractions really still are real numbers. And my c term is the other number, and it's going to be 0.4, which is a decimal. Any of our numbers can be negative, decimals, or fractions, so that's something you want to remember. Number 6, I've got 2x equals 4 minus 3y. This is not in the same order, but that's not one of my rules. I can still find a coefficient of the x term. So A is 2. I can still find a coefficient of the y term. So B is negative 3. The other number that's left over is what C is equal to. So any order, they can be written in any order. They can be written on either side of the equation. If I can find the x term, the y term, or the x term or the y term, and a c term, and any of those could be 0, I have a linear equation in 2 variables. So it looks like almost anything can be a linear equation in 2 variables, doesn't it? How about some bad examples? Take a look at the bottom of the page. What I've got is 2x squared plus 3y equals 4. Now, if you remember the rules that we had at the top, this is not allowed. What's not allowed? Exponents. Exponents of the variable terms. We can't have anything other than 1. So no, this is not a linear equation in 2 variables. Second example down there, 2x is equal to a square root of a negative 3. Well, the square root of negative 3 is not a real number. The square root of negative 3 is an imaginary number. This one doesn't fit the bill. And the next one, negative 2x minus 3y plus 5z equals 4. Well, I'm not allowed to have variables that are not x and y. This has a third variable, 5z, so it doesn't work. And the final one, 2n minus 4, equals 4 minus 3n. Those n variables have to be either x or y's. And I don't have an x or y term, so this cannot be a linear equation in 2 variables.